Assalamualaikum and hi everyone. My name is Nur binti Muhammad Faizal, a student from Faculty of Computing and Media Technology. And in this video, I will explain the topic of system structure in operating system as part of my individual assignment for course DTN3043. System structure refers to how computer components are arranged and how they work together to carry out computing tasks like receiving input, processing it, and producing output. At the highest level, the computer system consists of four main components that work together to achieve its purpose, which is to compute. These components are input-output devices, the processor, which is also called CPU, memory, and system bus. Input-output devices are used to transfer data between the computer and the external environment through input-output ports. These devices are divided into two parts. The mechanical component, which is the physical device, and the electronic component, known as the controller chip. Operating system mostly interact with the controller chip, which is responsible for managing data transmission. These are the examples for input-output devices. The processor, often called the Central Processing Unit or CPU, is the heart of the computer system. It controls all the operations and performs data processing by executing instructions stored in the memory. Each instruction cycle involves three main steps. First is fetch the instruction from memory, second is decode the instruction, and third is execute the instruction. This execution is timed by the system clock, which sends pulses to the CPU to trigger operations. The CPU has three major internal components, which is control unit, which is also called CU. It controls all the activities in the computer. An arithmetic logic unit, which is also called ALU, and this performs the mathematical and logical operations. And lastly, the registers, which is a very fast memory used to store intermediate data and operands. Memory stores both data and instructions. When the processor wants to read data, it sends the memory address through the address bus and the read signal through the control bus. The memory then outputs the data to the data bus, which the CPU reads. Instructions are executed into two phases. First is the instruction fetch, and the second is instruction execution. This cycle repeats for every task that the CPU handles. Here's an example of fetch, decode, execute process. Here are listed out the function of each component. As you can see in the memory, 0, 1, 2, 3 are the addresses for the instruction and data. The address 0 is first updated at PC and then MAR, and then the load 2 is uploaded from memory into MDR and CIR. The instruction load 2 is then sent to control unit to be decoded. Now PC can move to the next instruction, which is 1. But first we need to execute the load 2 instruction. So we need to upload the data in address 2, which is 13, into the MDR and accumulator. So now we can move to the next instruction at address 1, which is sub 3. So sub 3 is uploaded into MDR, CIR, and then moved to control unit to be decoded. To execute sub 3, the MAR has to be updated into 3, and the data 8 has to be updated at MDR and ALU. Now we retrieve the 13 from accumulator and upload it into ALU so that the ALU can carry out its mathematical operation. Important feature in system structure is the interrupt. An interrupt is a signal that stops the current CPU process to run a different task called an interrupt service routine. There are two main types of interrupts. Software interrupts are triggered by system calls or programs, and the other one is hardware interrupts, which is triggered by hardware events like keyboard input. Hardware interrupts can be maskable or non-maskable. Maskable means that it can be ignored or delayed, while non-maskable means that it must be handled immediately, for example as memory errors. To summarize, a computer system structure involves coordinated interaction between input-output devices, the processor, memory, and system buses. The operating system plays a key role in managing these components, handling device control, executing instructions, and responding to interrupts. Without this structured interaction, the system cannot function efficiently. Well, thank you for watching, and I hope this video helped clarify the essential structure of operating systems.